Hi, and welcome to Dr. V's AP Chemistry webcast. Today we're talking about factor label. Sometimes it's called dimensional analysis. And this is a strategy for problem solving that is very important. You may be asking yourself, do I really need to know this? It's math, you said. It's a chemistry class. Do I need to know it? Absolutely. I can't emphasize enough how important it will be for chemistry students to master this. It is used a lot. Anytime you have to do conversions from one unit to another, factor labels the strategy you want. If you have stoichiometry problems to solve, and I assure you there will be stoichiometry problems in your chemistry class, this is the fastest way to solve them. And when you are working with a time limit, if you've got a timed classroom test or a timed AP exam, or just you've got stuff to do in lab and you need this answer, you want to do it quickly and efficiently and correctly. Factor labels your best way for making sure that you've done that. So you want to master it. You will do better in chemistry. So let's start by looking at a very typical problem that would use factor label. It's not a chemistry-based problem. It's a unit conversion problem. How many centimeters are in 6.2 feet? All right, well, this is something you can do. You can get out your calculators. It's not a difficult problem to solve. Let's think really about the strategy here. The first thing that really you should do when you've got a problem to solve is to list out what you know. All right, so starting with what information are you given? Well, I've got 6.2 feet. That's a measurement that was taken. Okay. The other thing you might want to do is, well, what am I solving for? In this problem, that's actually quite straightforward. I'm solving for centimeters. I want to know that conversion, but I don't have a nice, simple centimeter to feet conversion set up in my head that I can write down. So the next thing I want to think about here, what are the conversion factors that I do know or I can look up? All right, so anyone living in the US knows that 1 foot is equal to 12 inches. So we can write that as an equality, which is what I have here, right? There are 12 inches in 1 foot by definition. And I can write that as one of two ratios. I can write 1 foot over 12 inches or 12 inches over 1 foot. And when I am in the middle of the problem, I'll pick which ratio I want based on the way the units work out. It's called factor label because the units I don't want are going to disappear. I also know that 2.54 centimeters are equivalent to 1 inch. And this is a really useful conversion factor, one I recommend you memorize if you don't know it already. So again, we've got it as an equality. We can write it as one of two ratios, 1 inch to 2.54 centimeters or 2.54 centimeters over 1 inch. Again, we'll choose which version we want so that the units that we don't need disappear from the problem. They cancel out. That's why it's called factor label. So now that we've listed out what we know, we can start to set up the problem. We know we're solving for centimeters. How many centimeters are in 6.2 feet? So the way I always do these problems, I write x, what I'm solving for, equals what I'm given. X centimeters equals 6.2 feet. I want to do this conversion. So I want to take my feet. I know I can do feet to inches. And then I know I can do inches to centimeters. So that's really the key. It's a two-step problem here. So I want the unit of feet to disappear. So I'm going to multiply it by 12 inches over 1 foot. All right, because now the unit of foot disappears, cancels out, and leaves me with inches. Well, I'm not solving for inches, so I'm not done yet. I have one more conversion that I need to do. I know that there are 2.54 centimeters in 1 inch. I want the unit of inch to cancel out, so I'll put inches in the denominator of the next conversion factor. The unit inch disappears, cancels out really, and I'm left with centimeters, which is what I'm solving for. So because the units that aren't what I need at the end have canceled, I'm left with only what I need. I know I've set this up correctly, which is a good thing. I'm much more likely to get the correct answer. So now I can get out my calculator and crunch the numbers, estimate my answer, and round it properly and calculate it. I know that since I'm multiplying by 12 and then by 2.5, my answer is going to be much larger than 6.2. I could estimate that if I wanted to. But when I do that out, I get 188 centimeters. Great. But I also noticed that the initial measurement, 6.2 feet, only had two significant figures. So my answer can only have two significant figures. And so I'll round it to 190 centimeters because we try to be good about that. One thing I want to just point out here is that the inches to foot conversion, that's really a standard definition that has unlimited sig figs. it's not going to limit our answer. 2.54 centimeters to 1 inch, again, that has unlimited sig figs. It's not going to limit our answer or change our precision. So the 6.2 feet measurement is what we're assuming is what will determine the precision of our answer. And that's why it's 190 centimeters when we're done. All right, let's go on and do a more typical chemistry problem. A reaction stoichiometry problem. When copper metal is immersed in a solution of silver nitrate, you make silver metal along with copper 2 nitrate. And this is a very classic single replacement reaction. Perhaps you've done it. And here's the balanced equation. It's a stoichiometry problem. You do need to have a balanced equation, of course. So here we go. And the question is, well, what mass of copper metal is required to react with all the silver from a silver nitrate solution that contained 0.20 grams of silver nitrate? Okay, so there's a lot going on here, right? We've got that balanced equation. Let's think about our steps. The first thing we want to do is list what we know. If you go back and look at that previous slide, and you can certainly scroll back or rewind a little, what are you solving for? Well, we're solving for the mass of the copper. In grams, it didn't specify, but grams would be the easiest thing. What are we given? Well, we know that the solution had 0.20 grams of silver nitrate in it. We want to react all of that. In terms of conversion factors, there are 3 things we need to know. From the balanced equation, 1 mole of copper reacts with 2 moles of silver nitrate, so we have a 1:2 ratio. The stoichiometry problems are always going to have a mole-to-mole conversion as one of the conversion factors. We need the molar mass of copper. 1 mole of copper is 63.55 grams of copper. And we need the molar mass of silver nitrate, which is 169.88 grams of silver nitrate for each mole. So that's all the information we need to solve this problem. So now we're ready to set it up. Okay, so I want to know how many grams of copper metal do I need to react with 0.20 grams of the silver nitrate. So I need to take my grams of silver nitrate and convert it to moles, because you always have to go through moles with the stoichiometry problems. All right, so I have to divide by the molar mass. All right, but look at the conversion factor. That means I've set it up with the molar mass in the denominator so that the grams of silver nitrate cancel, leaving me with moles of silver nitrate. I know that 2 moles of silver nitrate react with 1 mole of copper. I get that from the coefficients of the balanced equation. So the mole of silver nitrate unit cancels, not the numbers, just the units. And then I can take my moles of copper and convert that to mass of copper in grams. So I know that 1 mole of copper has a mass of 63.55 grams. So the unit moles of copper also cancels out. So now I know that since my unit remaining is grams of copper, that matches what I was solving for, I can go ahead and get out my calculator and estimate this. Now I'm looking at it, I'm dividing by, 170 and then dividing by 2 and then multiplying by 63. I'm going to get an answer that's smaller than my original 0.2 grams, and that's fine. It's just a nice check on yourself. And when I go through and do all the math, I get 0.037 grams of copper as my answer. So factor label is far and away the most efficient strategy you can use for solving stoichiometry problems quickly, efficiently, correctly.